So today we will mainly focus on the homogeneous linear ODE. Okay, homogeneous linear ODE equations. And it separates with different scenarios and the solutions will look differently. So there is one type. So first we will write yn plus pn minus 1 x yn minus 1 prime plus dot 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 p1 x y prime plus p0 x y equals to 0. That is the homogeneous linear ODE equations for higher order. There are different scenarios. The first scenario is all the coefficients are constant. Constant coefficient equations. And we usually guess the solution for constant coefficients higher order homogeneous linear ODE is the form of exponential, so e to the x. Another is called Euler-Corsi equations. And we usually assume that solution is x to the m power. And we will talk about what is the form look like for Euler-Corsi equations. There is another one, it's called variable coefficient case. And we will introduce later on for this case solution is the power series. Okay, is the power series. And we will talk more detail regarding this type in the power series lectures. So for these homogeneous solutions, for example, if the coefficient is all constant, we can rewrite this form as constant coefficient, y to the n plus a n minus 1, y to the n minus 1 prime, plus dot 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 plus a1 y prime plus a0 y equals to 0. And you know that the solution form will look like the exponential part, right? So we will assume our solution, which is zx is equals to e to the lambda x. You know it will consult with different arbitrary constant there. So we assume the solution form is e to the lambda x. And when you put this e to the lambda x back into your linear ODEs, that will be lambda to the n e to the lambda x plus a n minus 1 lambda n minus 1 e to the lambda x plus dot 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 plus a1 lambda e to the lambda x plus a0 e to the lambda x equals to 0. And you know e to the lambda x is a non-zero positive number there. So you can just cancel out all the e to the lambda x in this equation. Then you can get lambda to the n plus a n minus 1 lambda n to the n minus 1 power plus dot 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 plus a1 lambda plus a0 equals to 0. So now the solution look like a polynomial of lambda. So in order to get the final solutions, you basically just need to solve these polynomial equations to get root of the lambda. Then you can get what is your homogeneous solutions. So the root of characteristic polynomial, which the general characteristic polynomial is this above equations. And you can get the lambda, okay? So for second order, you should get 2 lambdas. For third order, you should get 3 lambdas, etc. Then for nth polynomial, you can get n number of lambda. And the general solution when your forcing function is 0, then the general solution should be your homogeneous equation solution, right? So the general solution is a linear combination of individual solution. So you get this yx, or you can say this is a homogeneous linear equation, that the solution is a homogeneous solution, will be a linear combination. So you sum of all the constants align with your each individual solution will be equal to Ci e to the lambda I x, because each individual solution is aligned with lambda I. So you solution form should be e to the lambda I x, and you linear combine them will be Ci, the sum of Ci to the lambda I x. And in order to confirm what is you Ci is, you need to specify, initial value problem or boundary value problem to give us specified conditions. So that means the n, so this is n linear independent solution form the basis of solution on the interval of interest. So basically, for homogeneous equations, you will conclude that n linear independent solutions, and this is the basis of your homogeneous solutions. And what is the definition of the linear independent, we will talk about later. So this is important. It has to be first linear independent solution, and that is the basis of your homogeneous, and there is n number for your nth order ODEs. Okay, we will talk about what is the linear definition means.